All right, we're recording, and this is the Kubernetes SIG Network meeting for March 8th. Yep, March 8th, 2018. Let's jump right into it. We've got a bunch of stuff on the agenda. So I think the first step was Dan Winship. You want to kick us off?
Yeah, so I think that PR, this is the network policy pod selector and namespace selector combined PR. Basically ready to go. Tim said he was happy with it. No one else has made any major objections. So I guess we're just, GitHub is complaining that it doesn't have a release milestone. I guess we're just waiting for 1.11 now or something like that. So I just wanted to point it out in case anyone who had an opinion hadn't looked at it yet. And, I wanted to make sure that I am actually right. We are waiting for 1.11, right?
Do we think it's actually safe to try to jam into 1.10 at this point? Like, can we make an argument for that? We sort of missed the boat.
Well, I mean, people would have to implement it as well, right? So.
Yeah. All right. I guess we are waiting for 1.11 then.
Yeah, I think that sounds right to me. There's no like urgency to it being in 1.10, right? It's a lot of people will like it, but there's it's not going to be the end of the world if we got to wait another 3 months.
I mean, I guess we could commit the validation change, but not the documentation changes, and then Kubernetes would allow people to define them, but we wouldn't actually say you could, and then people could implement it early if they wanted. But
it's probably better to do the other direction.
Okay, so yeah, so that's all. If people want to see it, they should look at the PR. That's it.
I looked. It's okay to me. I mean, there's problems, but there's, all solutions are bad. So that's the problem with this one typically.
Cool. Sounds good to me. Dan, maybe you want to... Oh, you've got the link. Cool. So people can find a link to that in the agenda doc. If that's it, I think we can pass it on to Dinesh, who wants to talk about App Switch. Dinesh, you on the call?
I can say yes. I'm here.
You've got the floor.
Okay. So this is kind of a different networking approach I wanted to run by the team here. I won't spend a lot of time in the background and things like that, but there's a link there which kind of explains the details of what it does. I mean, the one way to think about it at a high level is it is abstracting application networking in general to the application level. One way to kind of characterize this is it's kind of like containers for networking. I mean, exactly like what Docker or containers have done for compute. If you look at the compute stack, you have physical machines, virtual machines, and then containers on top, progressively higher in the software stack. If you look at the networking stack, so there's physical networking and then virtual networking, kind of the SDN and all that. What would be the equivalent of Docker on the networking stack, right? So that's just a high-level view of what App Switch is kind of supposed to be. Can I share my screen? I mean,
yeah.
Okay. I'm just going to open this link here just a couple minutes spending on the architecture of what this actually is like. So there's a bunch of detail in this paper. The link is this, but basically the architecture is like this. You can still see my screen, right?
Yep.
Okay. So this is kind of what it works like. So there's this app at the top, and the network API calls made by that app are intercepted by this uninspired name called trap generator. So it's basically generating the traps whenever the application makes any call related to the network. I mean, one way to think about this is it's kind of like network equivalent of Fuse. An application makes VFS system calls, Fuse forwards them to the user space. Similarly, when an application makes network-related system calls like listen, bind, connect, accept, get, sock, pop, those kinds of calls, they get forwarded to user space. Or the trap generator, there's a couple ways to implement it. In this particular implementation, the implementation that this paper talks about is a kernel-based implementation. It uses kernel trace points to trap the application system calls and then forwards them to this trap handler, which is running in user space. So then once those system calls are in user space, then the handler will decide what to do with those system calls. Ultimately, the only way for application to access network is through that API. So you can do a bunch of things at that point. You can say if the application is trying to connect to an IP address like 1.1.1.1, an arbitrary IP address. It can then change that name to a different IP address, or it might reject that call altogether, or it might decide to redirect that connect to one of the backend servers that would make sense for that connect to go to. So it basically opens up a lot of possibilities as to what kind of functions can be implemented at that layer. So the calls are handled by the trap handler, and then there is this shared service table which keeps track of the servers. When an application happens to be a server, by calling listen system call, it binds to an endpoint, and then it starts listening. At that point, it becomes a server. And the existence of that server is propagated to other nodes in the cluster. So there's this cluster here on the left. So in this case, there's 3 hosts, and the apps are running on top. And if there is an app like DB1 here, it happens to be a server, then the existence of this DB1 server is told to other hosts on this cluster via this gossip channel. So this service table kind of keeps track of all the servers in the cluster, and they get propagated to other nodes in the cluster. So when a client on a different node wants to reach that particular server, then it is connected back to that server. So the service table has an API. You can kind of think of it as IP tables. So IP tables acts on the packets that are flowing out and in of a system. In this case, we can call this SR tables. What this does is it allows you access to the in and out path of the system calls. So you can put a rule saying when a client tries to connect to this address 1111, please redirect that to some address, 172 whatever. So it's kind of built on top of this underlying SR tables mechanism and this mechanism which is kind of network equivalent of Fuse. And the service router is responsible for listening to the servers that are coming up on different hosts and propagating that information to other nodes or other clients that would like to connect to those servers. So I kind of ran through this architecture, but let me get to the demo. I'll just very quickly do a demo, and then we can start the discussion. I know I may not have a lot of time here. There's other things on the agenda. So at this point, any quick questions before I show the demo, or would you rather see the demo and then ask questions?
Yes, I'm a little unclear. I started to look at this a little bit, and the introductory verbiage was talking about, I thought, the sort of improper binding between addresses, IP addresses, and application identities. But if you're intercepting system calls that work with IP addresses, I mean, you have to work with IP addresses.
Yes, you have to work with IP addresses only to the extent of being backward compatible. I mean, there's existing applications that expect servers to be named in the form of an IP address and a port. But really, it's just a name. Internally, it converts into a 64-bit UUID. In fact, some of these things actually might become clear with this demo here. You can specify an arbitrary IP address of your choosing when you bring up an application, and then clients would be able to reach that server application on that identity. If you don't specify any IP address, you could just specify a name, and the clients would then be able to access that service through that name. If you don't specify either, then it's not a server. It cannot be a server. It would just be it can be a client, and it doesn't need an identity. Clients don't need an identity. So some of this is discussed in that paper as well. So the point is to really decouple applications from the underlying network artifacts and network in general. And IP addresses are convenient names just for backward compatibility.
Well, then you'd best get on with the demo.
All right. Okay. So what I have here are actually 3 hosts. The top 2 terminals here are host 0, and then there's host 1 and host 2. I'm going to bring up this Nginx server. The command here is actually AX. I give it an IP address, like I was saying, this IP address, and I run Nginx like that, and then now the server is running. And this IP address obviously has nothing. Actually, it has nothing to do with the interfaces on the host, and there's no interface with this IP address creator or anything like that. It's just completely virtual. I'm going to connect to this server here. Maybe I'll give it a different IP address, and I would connect to that. So if I did this, it connects, and in fact, because it's a client, like I was saying, it doesn't need any identity. I can get rid of this, and it would still work. Let me create another instance of Nginx and give it the same IP on this other host. So now I have 2 instances of Nginx running on host 1 and host 2, each supposedly bound to that same IP address 1111. So when I try to connect to that same IP address from a client, it actually gets load balanced across the 2 hosts. So it went to host 1 here, and it went to host 2. Right now it's using random, but basically there's no need to configure a load balancer and things like that. So you just give it the same IP address, and Nginx is bound to that same port. So then it just load balances. So I can also do microsegmentation. Let me get out of these servers here, and I can pass labels which specify some attributes to this application. And I would call this role. I would give it prod role, and so now this is running as a prod server, and again on the same IP address. I'm going to call this let's say test. I'm going to call this the test server. Well, okay, so no output here, that's fine. So now when I try to connect with this client, it won't be able to connect actually, because it's not a part of that one of these roles. It's neither prod nor test, so it won't be able to connect actually. But I can say labels role equals, let's say, test. Then it's going to connect to the only the test server. It will never go to the prod, even though both prod and test servers happen to be running on that same IP address. So this is kind of convenient when you have applications which have the statically configured IP addresses in their configuration, and I want to create multiple instances of that application on the same cluster. And each may be a different environment. We'll be staging, production, testing, and each time I bring up an environment, I don't have to reconfigure this application to go to production database. The IP address can remain the same, and I would appropriately redirect the clients to go to the appropriate database. So there's a lot of things that can be done, but this is a quick demo. We can take some questions now and then go into more details. I mean, a lot of this is actually described in that paper itself.
So I think we have maybe 5 minutes for questions if people have them, or we can continue discussing on the mailing list if people want to think about it a little bit.
Okay, I'll ask one other question. So usually when people talk about network innovations, they talk about how it can be incrementally introduced into the internet. I don't see that here.
This is actually, so this is something that we are using internally, in fact, with Kubernetes. And we didn't need to change applications or the network. In fact, in this particular case, not even Kubernetes. So the way we run this is we just prefix the application with this binary. It's a statically linked binary, and that's all there is. The same binary runs as a daemon and also as a client. And there's absolutely no other dependencies to this. It runs on Ubuntu, whatever distro. So it is actually transparent with respect to what changes are needed to the applications on top or the infrastructure, networking infrastructure on the bottom. So I mean, this is actually one of the discussion points, and that's the main purpose for presenting this here as well. What should be the right way to integrate this into Kubernetes?
Yeah,
right now,
it's absolutely not transparent. You're hijacking somebody's IP addresses.
This is exactly what would be needed if I mean, at least for our use case, when we have existing applications with statically configured IP addresses, and they are expecting those IP addresses to be available. So then you're able to present that IP address to that application. And of course, so this could be integrated into Kubernetes as a CNI plugin, perhaps, and you would make up an IP address and assign it to the pod. And I mean, just like how Kubernetes creates IP addresses through IPAM and assigns to pods, the same kind of thing is possible here.
Okay, maybe I was a little too hung up on the introductory words about identity, the different form of identity. So maybe the right way to think about this is you got a different implementation of load balancer.
Load balancer, firewall. I mean, yeah.
Like, I think it's kind of like we've talked about in the past. Like, you can implement policy at different layers. Right? You can implement it at the network, like an SDN type layer or the service discovery layer. And this is kind of another way to do it. It looks like basically right.
Yeah, that's one way to think about it. It's kind of like, application level SDN is one way to think about it. In an overlay, you are creating a different layer of IP addresses, and you can do that even here, except you are not changing every packet. You're not in the data path at all.
We have a question here.
What does this look like when you debug it on TCP dump?
Not unlike...
Like, well, what would the addresses look like?
They would be host addresses. So they get translated, right? So when the application is binding to 1111, that actually gets translated to an IP address configured on the host interface. So you will see host IP addresses.
I see. And then why, can you give a strong motivation for having static IPs all over the place?
No, they don't have to be static. In fact, I mean, in this case, right? So when let me cancel out of this, I could have given it a name. I could just do this as well, -- name server. And
but how does the naming work? Because like you're intercepting at the syscall, so I guess you also intercept get host by name and all those.
Yeah, that's one. Yeah, right. Yeah. So basically, application's view of network is completely virtualized, and made to be consistent.
I see. How does that work? Because get host by name is not actually a syscall.
Yeah, get host name is not a system call. In this particular implementation, there is a built-in DNS server. So, for example, I could do this, right? So I just did that, and label test prod. So I'm going to make this prod.
So why can't you just do the redirection at the DNS layer?
Sure, you could do that. So right now, see, I just did it with the name and it works. But we have a different implementation which is able to intercept at the library layer as well. And in which case, you don't need to run the DNS server. You would just intercept all network API and return the appropriate consistent results to the application.
Yeah, I guess I'm trying to understand why you have to go to that layer.
So you don't have to be in the data path. See, right now, let's look at kubeproxy, right? How would you implement something like cluster IP? Cluster IP is a fake IP, and you're connecting to it, and you can program IP tables to convert all references to that IP to the real pod IP. In this case, I'm not in the data path at all. I only intercept the connect once, and it's as if the client is already connecting to the right server at its right identity.
I guess, yes, but why intercept the connect? Why not just return like the discovery? Oh, I guess you want to do it on a per connection basis. Is that the reason?
Not just that, applications, it needs to work for any application, even applications that don't rely on, that may not use DNS. They might have some statically configured IP addresses in their config. It should work then also. So there's different places you can do this indirection. You could do it as a proxy. You could do it at DNS, but some applications may not use DNS. Then you would lose control. In this case, the interception also is done at the kernel. So even if your application is statically linked, like most Go binaries, it would still work, as opposed to other approaches like LD preload. So the focus is the breadth of application support. It should generally work for any application. And in fact, we use this for specifically legacy applications like WebLogic, SAP, JD Edwards, those kinds of applications.
Can you talk about what the AX command is actually doing?
Right. So in this case, all it is doing is it is telling the kernel to start tracking itself and then executing the application. And then it is also telling the daemon, there's a daemon running, by the same name, actually. So if you just look at this, so there's, so that's the daemon, and it's again the same name, and it tells the daemon about the attributes that have been passed on the command line, and then it tells the kernel to start tracking this application, and then execs. And then the AX command, the client's out of the picture, and it's really the application that's running directly on the OS, and its system calls get forwarded to this daemon. And the daemon is obviously talking to daemons, its counterparts on other nodes in the cluster, and then exchanging routes and things like that.
Is there a way to do this without changing the end user's containers?
Absolutely. There's no need to change the container, actually. I have, this is not really out yet, but we are going to do a little release. So I can show you how you would do that here. So you would just run. I would just mount the binary into the container like this. So that's the binary, and I'm mounting it into the container, and then make that the entry point, and then run any arbitrary container off of the repo, and it works.
So while I guess that meets the strict definition of not changing their container, that would be frowned upon by people who are security conscious if we were to do that by default. I'm looking for, is there a way that we can do this more transparently without injecting anything that the user could see, touch, smell, or taste?
Absolutely. See, there's one way. I mean, this is exactly the discussion that I wanted to have. So there's a trade-off here. See, one way to do this kind of tracking is at the namespace layer. I could create an additional container in the same pod, and that container would basically enable tracking on itself, and all the processes in that network namespace would automatically be tracked. So you can have transparency, but then now you have a dependency on having the network namespace, which unfortunately requires privilege. In order to create the network namespace, you need privilege. But at least then you won't need the wrapper. You don't need to have this AX prefix.
So you could inject. Sorry. So you could inject this as a container within the pod. That container itself would need privilege, but the rest of the pod doesn't. Yes.
In fact, that container also wouldn't need privilege. Whoever creates that network namespace obviously needs privilege, and I guess that's fine. So creation of the network namespace needs privilege. In this case, if you are willing to have the AX prefix, then you actually don't need privilege. You can.
Sure, but for Kubernetes, we can assume that the network namespace already exists. So if this were integrated, for example, into one of our CNI drivers, it would flip some bits in the network namespace in the kernel, and then any further commands would automatically be wrapped?
That would be the first thing you would run in the pod. And then, in fact, that container can die right after running once, where it enables the tracking on that network namespace as a whole, and any subsequent container that's running that pod will be tracked. That's one way to implement it. So it's a trade-off. I mean, we've been thinking about the right trade-off here. Is it okay to have the AX prefix and not need privilege, or is it better to require privilege? At least you're not requiring privilege for AX. It's you can create a network namespace outside. You can just do IP netns add, but that requires privilege. Once you have the network namespace, then you can exec into that network namespace, and then you won't need privilege after that.
But if you already have a network namespace, then you don't need to do anything special, right?
Yes.
You don't need another namespace.
No, you don't. No, you don't. If you already have, that's fine. So the exact way to implement it, we are kind of thinking through, and that's exactly the input we wanted by talking to you. Yeah.
Cool.
Okay.
Thank
I
you.
feel like we're probably out of time, but I'm sure we can take this to the mailing list. Can you send links to your docs and stuff to the mailing list?
I will do that, and yes, I'll do that. And by the way, you can reach me at how can I share? So my email address is.
You could just add it straight to the agenda doc if you want,
okay.
or
or you could send email.
Send something on the
Right.
Okay. Sounds good. Thank you very much.
Thanks, Dinesh.
Thank you.
Yep.
So next we've got a discussion of the Kubernetes enhancement.
Yeah.
Yep.
Yeah, this will be quick. I just wanted to get everyone's thoughts on maybe adopting using KEP for the SIG. For those who don't know, like Casey said, it's Kubernetes enhancement proposal, and I believe it was a methodology started by Joe Beda. And essentially, it's just a much more formal way of stating your proposal for your feature, as well as a lot of other things, such as like testing requirements, graduation criteria, a lot of other stuff. And I think lately we've had a lot of like questions and stuff on big features, like when can this go GA? When can this become default? And that makes us wonder, like, what are the requirements for all of this? We don't really have a set thing to look at. And so we're always kind of scrambling for requirements there. And so this would kind of allow us to formalize that. And it's not a big deviation from what we already do. Like, we already have like feature proposals and all that. And so this wouldn't be a big deviation from that. It's just adding on to it. And so if no one is opposed, what I can do is create a folder for the SIG under the top level KEP directory, and maybe put in like a reference KEP. I was thinking maybe working with the Huawei guys on an IPVS one. since we want to go GA with that in 1.11. And then maybe in the future we can use that as a reference and build on that.
I just have a question.
Yeah.
I'm sorry. Yeah, I missed the introduction to KEPs, so I'm just learning about them this afternoon. So I have a question here.
Okay.
I'm looking at the workflow in the document. Is this KEP/Kubernetes Enhancement Proposal Process.md graduation criteria? So it wasn't clear to me exactly what graduation means, and more specifically in the workflow, there's a distinction between provisional and implementable, and I'm not clear on what's the distinction. I think the first question maybe is technically, when does the first PR actually get merged? Right? It says to become provisional, the SIG has to agree that this is work that needs to be done, but that's often the biggest hurdle and needs the most discussion.
Yeah. I think where this KEP would come into play is after a feature has actually been agreed upon to be implemented. Like, you wouldn't go through all the work to do this unless your feature is actually going to get like started, right?
But what's the difference between the SIG has accepted this work needs to be done versus implementable?
I would say that's the level of detail.
Yeah, I mean, these are all like small little things, but I think we can flesh all this out. Maybe I can write that reference KEP and we can take a look at it next meeting and see where we want to make changes, because there's a template. We can make modifications to the template as we see fit for our SIG.
And for what it's worth, we'll eventually have to do it. KEP is still sort of in trial across volunteer SIGs, but we'll eventually have to be part of some standard process.
Yeah, it makes sense to have some process. I was just looking for some clarity.
Yeah, you know, the folks who are driving KEP, Joe and Caleb, and to some degree Brian, are very open to questions and feedback from different SIGs and see how it applies to different contexts.
Yeah, I mean, it seems like we should definitely try it out, especially at this stage where we can give feedback if it makes sense for us or not.
Yeah. Okay. So I'll have something for everyone next time, a more concrete kind of thing we can look at. That's it.
Cool. Thank you. Next on the agenda was Francois.
Yes, hello. So I'm here to talk about core DNS and how we finish integration of core DNS. So first, we are good for beta. Thank you very much to everyone that collaborated for this review approval. But it took a very long time. So it's done for beta and version 1.10. I would like to anticipate the plan for the GA and I guess 1.11. So my question here is it okay for 1.11 or do we wait an event, validation, something for saying okay GA for 1.11? What do we do once we go GA? What do we do with kubedns? I mean, right now, if we make core DNS default, you can still install kubedns if you say, I don't want core DNS.
So I think the very first step is to come up with the exit criteria and then have everyone kind of agree that it makes sense. Like, for example, you ran it on our 5,000 node scale, things like that. And then based on that, right, and whether or not all those bars are cleared or not, then we can decide which release.
Okay.
Do we have a place we've been documenting the kind of graduation criteria for this?
That's sort of the KEP conversation.
Yeah, I was gonna say, presumably if we had a KEP, we could.
I mean, I don't know if whoever wants to take the time to do that, but yeah, that's.
It might be worth doing a retroactive KEP for core DNS.
Same thing with IPVS.
Yeah.
Yeah, that makes sense. We could do that. I think we also have some questions around what the current convention are. Maybe this is more for SIG lifecycle, but today, like if you upgrade or you modify the manifest of DNS, during the upgrade process, do these things get? I guess it depends on the deployment, how you're doing the deployment, but in Kubeadmin say, do they replace the existing manifest? I mean, if somebody's customized that manifest, how
It's
do we
gone.
preserve that? It's gone. Okay. So we
It will-
want to follow the same
really-
procedure. So we need to, and we'll bring that to SIG lifecycle to make sure, but I just wanted to get an idea of how we're doing it today. If anything.
Yeah, I would say that's probably one of the exit criteria would be to understand for a cluster with a kubedns config that's been tweaked, what is the transition plan? Is it manual? Is it going to just blow things away? How's it going to work?
Okay.
So, so that is the execution criteria. I still have two other questions, if that's possible. One is, as soon as, let's say, even if it's not 1.11, that will happen later or whatever, as soon as we make default core DNS, then a bunch, not maybe all integration tests, the end-to-end test that runs in the dashboard or are visible in the dashboard will run with core DNS, maybe not all. How do we synchronize that with the people that are running end-to-end tests? Or do we advertise the core DNS is a default? I mean, that may have some impact on people, and some other will have to translate their tool to, to upgrade their tool of deployment to use core DNS or not. I have to deal with the SIG testing, for example, for that.
Sorry, is the question just how do we tell people that it's time to switch from kubedns to core DNS?
Yes, and yes.
The good news is that they don't have to do it like instantaneously, right? They could, if they lag behind, it's fine. They're just going to be using an older version of kubedns. And so we start the outreach to people, and we send deprecation notices for kubedns, and we, let everybody that we can find know. We scream as loudly as we can that this thing's going away.
Okay.
Yeah, also probably the plan is part of the graduation criteria.
Yeah, I mean, it'd probably be good for the KEP to figure out exactly where should we be advertising this, and how long are we going to let the overlap exist, and what are we going to do with kubedns at the end? Are we going to delete the repo? Are we going to move it to the graveyard? Are we going to
just don't delete the spec?
leave the directory there, but just with a readme file? There's 10 different things we could do. I don't think we have any real established precedent in this case. I don't think we've ever had a project replace another project.
Yeah.
And also, we should talk about release engineering for the core DNS builds. Where does the binary come from? Where does it get pushed? Who's building it? What tests it goes through in order to cut a release?
Yeah, that's exactly what I was about to ask about. I know we've discussed in the past that we would want it to be in the gcr.io, and that there was a plan, and I don't know the status of that plan today, to be able to do some sort of continuous integration on some of these components, and then drop them in a registry when they're ready.
Yeah, and there's some who believe that as part of the Kubernetes release, we shouldn't release any binary or container that we didn't actually build ourselves, and which would imply probably from a RelEng point of view, we should keep a fork in the GitHub sense of core DNS in a repo related to Kubernetes and cut releases from there. We can have that discussion too.
Okay.
All right. So that means we prepare this graduation criteria and evaluation, and we will present it on one of the next SIG network that will happen in this meetings.
Okay.
Yeah, I think if we can, it would be good to try writing up a KEP for that. That includes the requirements, and then we can go through the standard KEP review process.
I just want to reiterate that I think this is the first time we've done this, so we're going to make up some of it as we go.
Okay.
And I just created a directory for us on the communities/KEP, so put it under there.
Awesome.
Cool.
Okay.
So I think we just got one thing left. Minhan, do you want to talk about pod readiness?
Sure. So I sent out a proposal called Pod Ready++. I presented the problem statement a few meetings ago. So essentially it is, so there's a disconnection between pod lifecycle and like networking constructs like service, network policy, ingress, and etc. So the workloads essentially are the orchestrator of the pods is ignorant to like networking and the constructs. So this is not a problem when the system is stable and everything is programmed. It becomes a problem during transition, like for instance, rolling update or like there are disruptions or things like that. System like kubelet and the pod has to restart and network programming has to be done. Like during that period of time, there's no proper feedback loop from the networking side to feedback into the Kubernetes API to basically tell the orchestrator the workloads that like what to do. Right now, the orchestrator, the only signal for the orchestrator is pod readiness, and the pod readiness is dictated by kubelet, which is only on the nodes, right? Only inferences on the node. So, so this proposal aims to add an extension point on the pod readiness to allow additional feedback, either from networking constructs like services, network policy, and etc., to feedback into pod readiness, so that the workloads automatically like consider the programming and the readiness of networking components. So we went through a lot of iterations internally at Google. We went through a lot of discussions, and this is the proposal that we finally came out with the most surgical fix to the Kubernetes API without like redesigning a lot of core objects. So feel free to take a look and see if there's any like recommendations, suggestions, yeah, and objections.
Please take a look. I suspect that many people have run into the same problem, but maybe not identified it or not known how to deal with it. We'd like to make sure that we solve sort of the whole family of such cases.
Yeah. So the alternative is of like, let's say if we don't solve it in the Kubernetes API, what we'll probably end it up with is that like everybody gonna implement their own workload. Like for instance, Istio, they are planning to implement an Istio deployment, which is aware of networking components like their Istio constructs, and then the users can only like interact with the Istio deployment to like work with other like Istio networking like other setups. So basically, this make the workloads very limited. Like for instance, someone want to deploy like Quark or something. Those operators, those third-party operators, they don't have they have to re-implement everything, right? They have to re-implement the hooks to watch services and network policy and etc. That makes their life much harder. So with this proposal, basically gives the extension point needed for specific features that to feedback into pod readiness and then influence all the other workloads. Okay.
So reading the proposal, I wonder, why is it opt-in? Like if you're going to agree that a pod isn't really ready until kube proxy and network policy and stuff like that are all aware of it and ready for it, then under what circumstances would you ever want a pod to be considered ready when those things weren't updated?
So that's a good question. So it is it can be opt-in or automatically enforced, right? Like for instance, using mutating webhooks. Like for instance, the user doesn't need to, the Kubernetes user doesn't need to be aware of like there's an extra readiness from your pod. They just write like their own pod spec, and then when they create the pod, the mutating webhook will inject this the readiness gates for their pod, and then they will automatically get those benefits, so that the users doesn't necessarily need to be aware of this change. It's the individual feature that has to basically line up the dots. For instance,
Okay. Yeah, I was just skimming now and I missed that. Okay, that makes sense.
Yeah, I think that's going to be the vastly most common way of this being engaged.
That reminded me of two questions I wanted to ask about that. One is why a webhook instead of something in process? And the other question or observation was, this makes it a cluster admin decision. Could there be cases where it is more DevOps, the guy deploying something decides what should contribute to his pod's readiness?
So I think that the DevOps person can seed those fields with interesting things that, like if they want to do some manual verification before they flip the ready bit, they can put the field with, wait until Mike says it's okay. And if they are running in Google Cloud, we will automatically add the, whatever foobar or frobnicator thing that we need for our stuff.
Okay, yeah, that's a good answer. So the DevOps guy can add conditions of his choice.
Right. I think that's right. Yeah.
But it's just that the DevOps guy, whoever adds it, needs to ensure that the pod, the pod condition presents. Otherwise, it will consider it as false, and then it will never be ready.
Right.
Well, obviously, that's the definition of how it works.
But they broke it, right?
Yeah.
I would also like to point out that this proposal is the result of literally months of work, going through, not kidding, no less than 10 different designs of ways it could work, that Minhan kept thinking we had it. Even I thought we had it nailed, and then Brian would shoot it down, and then we thought we had it, and then Airtune would shoot it down. And it was back and forth for months. So I really appreciate all the work that went into getting the design to a place where it is this simple.
Yeah, it is relatively simple, so I like that. So why webhook instead of in process?
The webhook is like the extension point provided by the API machinery to allow cluster admins to inject stuff, right, to control objects. So in process, you're basically implying that you have to compile and contribute your code, feature-specific code to core Kubernetes API machinery.
Let me try this again. There are some in-tree controllers that are going to want to set conditions that are relevant here. For those controllers, why make them go through a webhook? They could have their mods done in process in the API server, right?
Yeah, they could. But more and more of those, I think anything that's in tree that would want to set this is moving out of tree anyway, specifically the cloud provider stuff. So at the end of the day, it doesn't matter how the field gets there. Mutating webhook is sort of the extension mechanism for third parties. If we had an internal need for it, then it could be a real in-process administration controller too.
Wouldn't kube proxy be an example of something that should be setting a condition?
Yes. Yes.
Ideally. No one has noticed because it's so low.
It's fast enough.
Whoa, wait a minute now. I've heard people complaining. Right? We talk about when you get a bunch of services, updating those IP tables rules takes time.
Yes. So yes, you're right. Kubeproxy could be one. Kubeproxy is interesting because it's not one, it's n, right? You have to have something that aggregates and waits for all nodes to check in before it's ready, or some preponderance of nodes, or we'd have to work through the details of that. But sure, I can see how that would work.
Yeah, the main reason that kubeproxy escaped from this is that it's hard to find evidence. It's kubeproxy.
Yeah, it's like the princess and the pea. Would you notice?
I'm sorry, but I've heard from people complaining about this. I can send some your way if you want.
It's only crazy people. If we have just a couple minutes left, I'd like to put a shout out for the doc that I shared this morning. It's basically, it's a very short introduction, but I promised last week that I would write it, so I did. It's an introduction to a bunch of topics that are they feel related to me, including the evolution of ingress and integration with Istio and service topology and other things. I shared it to the group this morning. I welcome any and all feedback on it. I will start resolving comments tonight, and we can discuss the evolution of these family of APIs.
Oh, also, not entirely related is the ingress survey data is out. So we had pretty good response rate, like 240 plus respondents. If you're curious about that data, I emailed out a way to get at it. You want to take a look?
It's very interesting data. Basically, they want it all.
Of course.
Cool.
And,
I think. Oh.
Sorry, can I ask one more question? Is any of the IPVS gang? No?
Doesn't look like it.
No, it's late for them, so maybe they're not here if they don't need to be.
Yeah.
All right, I'll take it to email. Thanks.
All right. I think that probably wraps us up. Thanks, everybody.
Thank you.